I'd like to introduce the shimmering pythons for our heart attack risk predictor. If y'all want to take it away.
According to the Centers for Disease Control and Prevention, heart disease is the leading cause of death in America. Our group wants to spread both awareness and information. With this project, we will have the opportunity to save lives and help others by predicting a heart attack before it's too late. This system is able to predict the risk of a heart attack based on multiple input factors through user input. These factors are calculated to predict the user's risk of a heart attack. We experimented with many models in Python, including KNN, SVM, random forest, and logistic regression. Can you scroll down a bit? Okay, thank you. So sex and age are measured by the risk of angiographic disease in this violin plot. Neither age or sex correlates to the risk of a heart attack, as the plot shows that a person of any sex or either sex can have similar risks for a heart attack. Resting blood pressure is measured by cholesterol, and the size of the dots shows the type of chest pain. We can see that there's not much correlation between resting blood pressure and cholesterol. This heat map shows the correlation between factors in heart attacks. As you can see, OPEAK and SLP have the highest negative correlation, and CP, the type of, chest pain, and the output have the highest positive correlation. This bar graph shows the correlation of a patient's risk of a heart attack to every other health factor to determine the relevance of specific health factors. The factors with the highest correlation are ranked toward the left, and as you can see in this data set, exercise-induced angina has the highest correlation with a heart attack.
Chest pain. How does chest pain affect how much a risk is a person at for a heart attack? We measured the type of chest pain and correlation for the risk of a heart attack. This graph shows that not inguinal pain, atypical inguinal pain, or asymptomatic, you are at a higher risk than people with typical inguinal pain. Resting blood pressure. How does resting blood pressure affect how much a person is at risk for a heart attack? We measured the correlation between resting blood pressure and angiographic disease status. This graph shows that there is no correlation between a higher blood pressure and being at a higher risk for a heart attack. K-nearest neighbors. KNN works by finding the distance between a query and all the examples in the data. Selecting the specified number of examples, K, goes to the query and then votes for the most frequent label in the case of classification, or averages the labels in case of regression. Baseline accuracy. We achieved an accuracy of 78% without any standardization. Standardization of the data and setting numbers of neighbors to 11 increased our accuracy score to 88 or by 10%. That's our confusion matrix.
Logistic regression is a type of linear regression that predicts the the probability of a linear event for a logic function called maximum likelihood estimation. MLE is a likelihood maximization method, hence the name, which sets the mean and variance as parameters most likely to produce the observed data. With logistic regression, we achieved a baseline accuracy score of 88.5, and we used sklearn for feature engineering. Our first model was liblinear, but this decreased our accuracy score to 86, and then we tried Newton CG and LBFGS, but both times they decreased our accuracy score to 85.
And the third model we experimented with was a random forest. Random forest models construct multiple decision trees. A single decision tree will look for one pattern or factor in the input data and will make a decision or an output. A forest may have hundreds of trees, and the output is determined by the votes of all the trees in the forest. So the baseline accuracy for the random forest model was 83%. And like linear regression standardization lowered the accuracy rating to 81%, but implementation of grid search CV raised accuracy score to 90%. So our data set was supplied by Kaggle, and we used Python as our coding language and pandas for data manipulation. As stated above, we experimented with different kinds of machine learning models, and then we used HTML and CSS to build this website.
Conclusion. Our highest baseline accuracy was 88.5%, and following standardization, many models also improved and increased their score. Random forest was improved also by using grid search CV. Standardization and feature engineering improved the accuracy score for random forest and KNN, but decreased the score for SVM and logic regression. Our accuracy may have improved if we had a larger data set and performed further hyperparameter tuning and feature engineering.
And here's our team. We get on like a house on fire. Thanks, Andi and Viola and Kan. It's super fun working with you. Great job presenting. It's a fun project.
Also, especially Jahir, who thinks that Canada is still dependent on Britain, which ended a long time ago.